So my name is Dominic Chell. I work for a company based just south of Manchester called MDSec. Day to day, most of my time is spent doing red team engagements. You can find me on Twitter under this kind of unimaginative handle of @DomChell. Just a quick disclaimer, I'm not a DevOps expert. The talk is mostly on red teaming and red team tradecraft, but just looking how we can apply some principles stolen from the DevOps world into red teaming. So before I start, I'm just going to give a quick story. So we're doing a phishing campaign. We put a lot of time into crafting the perfect payload. We send it to our user. We get a shell. The next thing we do is a little bit of situational awareness. We do a little bit of probing on the endpoint, check that we're in the right environment, see what privileges we've got. We have a hunt around, looking on the file system, see what we can find, see if there's anything useful to us. And suddenly, your implant dies. You've lost connectivity. What's the reason for this? So if we look into what the blue team sees, they've got quite a sophisticated EDR deployment. In this case, we're just looking at CrowdStrike. They can see everything that we've done. They've got a threat hunting team. They can see we've run PowerShell. They can see we've run ipconfig. They know everything we've done. They've kicked us out of the network. So what is the problem? Well, fundamentally, defenses are advancing. We're getting things like command line logging, PowerShell script block logging, sandboxes, EDR, EDPs, application whitelisting, AMSI. The blue teams are upping the game, and they've got all this fancy tooling that's supporting them. Now, this is a problem for us as a red team because we've got a growing investment. So a DFIR team can quickly burn an entire campaign that we've spent weeks or even months maturing, putting together, and building that trust with the user. And we've lost it very quickly because of our poor tradecraft. So what I'm going to introduce to you today is a concept that I've been working on within our team for a while. We've recently started using it on engagements. And it's moving away from the traditional tradecraft of actually running any operating system commands. What I want to show is that we can actually abstract ourselves from this concept and actually only perform a red team engagement from an IDE. We can do everything that we want to in code. Okay, so what challenges might this actually pose to us? Well, there's a few things that we need to be aware of if we go down this route. So AMSI, threat hunting, they've got memory inspection, so we need to be aware of that and how I'll show some concepts that I deployed in some tooling that I'm going to release to actually get around some of these. We need to be aware of injection techniques. So in this example, I'm looking at Cobalt Strike. Well, the PowerPIC can execute assembly commands in Cobalt Strike, use injection to inject a CLR into any arbitrary process, whatever you define in your malleable profile. Then how do we actually go about kind of building our tooling, delivering it into an environment, and running it? And how do we prevent this tooling getting identified and the DFIR actually identifying any of our artifacts, running them in their own environments? So these are some of the things some of the challenges that we might have. I'll talk a little bit about how we kind of approached it and how I kind of applied or addressed those challenges in the tooling that I developed. So the first thing I did was really, I had a little bit of experience with some DevOps concepts, and one of the, if you are a DevOps person, you're probably familiar with the concept of having your own continuous integration, continuous development pipeline. Every time you're wanting to run a tool, you're building something fresh. It's not, you're basically in a position where you can continually distribute code, continually distribute builds. And that's fundamentally what we want to actually do. We want to have a process and a tooling in place that will allow us to consume, build, and deploy our code within an endpoint continuously. Additionally, some nice things that would be good for us would be to have a pipeline that allows us to use all the existing tools that are out there. So a lot of the kind of red team tooling is developed in PowerShell or C#. So we might want to use those to basically get a foot up. We want it to be agnostic of any C2 platform because we don't want to kind of limit ourselves into using one specific implant. We want to be able to modify our tools programmatically on the fly. Apply customizations to existing tools. So, for example, maybe we want to run something like PowerView, and we bootstrap PowerView inside our own .NET, and before that we run like an AMSI bypass before we actually run our own .NET program. So we can do that if we've got the ability to modify any tool and any code before it's run. We can bootstrap our own code before to disable protections. But effectively what we want to do is perform this concept of offensive development in real time. So what I decided to do was kind of took these things that were nice to have and look at how we could kind of address them. So if you're familiar with C#, you're probably familiar with the Roslyn compiler. Basically allows you to compile source code in line using in C#. Again, you may be familiar with .NET Core. It's basically an open source version of the .NET framework. It's supported in Docker. So what I basically did was took Roslyn and took .NET Core and used them to build a CI/CD pipeline and used it to integrate into, well, in this case, Cobalt Strike, but it is agnostic of any C2 framework. So the tool I created was called RedPipe, and it consists of three specific components. So firstly, the loader. So the loader is basically compiled every single time you want to run something on an endpoint. And currently it uses the execute assembly command in Cobalt Strike, which will basically spawn any arbitrary command that you can define in a suspended state. It injects an unmanaged CLR into that. And that's basically the loader. What the loader will then do is it will talk over a reverse port forward to the CI/CD pipeline, and it will retrieve whatever projects that you want it to retrieve. So the projects are basically either existing projects such as GhostPack, so Seatbelt, all those kind of tools, Rubus, or it will basically take a command to generate an artifact. It will then execute those in memory or drop it to disk if you want to drop the artifact to disk. And then the third component is the actual engine, which is basically just a .NET Core web API that receives the requests for projects, compiles them in memory, and it will obfuscate them and encrypt them, deliver them back to the loader, and run them in memory on the endpoint. So if we look at this kind of process, we basically have your user operating on your C2 client. It's got an aggressor script that's built into Cobalt Strike, and you say, I want to run something on this specific endpoint. So you'll say, I want to run the loader and I want it to run like Rubus, for example. That will run execute assembly on the loader, go through the cloud, through the firewall, whatever you're using for your C2. The loader will run in memory again on the endpoint. It will then talk over a reverse port forward back through your C2 framework to the RedPipe API. RedPipe will build, modify, deliver the compiled tool in an encrypted format, keyed to the endpoint, back to the user, and then that gets run and you see the result. So in a nutshell, that's the kind of workflow of the tool. Every tool that you want to run with the loader has its own profile, and these are really easy to craft. Basically, it's just a block of JSON that looks a little bit like this, and you just tell it the name of the tool. You can point it to the source code of whatever tools you want. So I've just got all the tools, that the PowerShell and C# tools that I use in an engagement, just got them all sitting there in a directory. I just wrote a little profile script for each one of them like this. I just say, this is where the source code is. Compile it with this version of the .NET framework, and these are the dependencies, the reference libraries that I use in this tool. And then they get stored in a SQLite database, and they're accessible from the pipeline. So let's look at a very simple example, first of all. So, hopefully, let's make that bigger. Okay, hopefully that is big enough. So let's see if I can see it. So what's going on is effectively I've just started up the pipeline tool and I'm just running it in an IDE. So this is actually running on my laptop. The implant is actually on a separate network, talking through Azure CDN to an Amazon host, to over a reverse SSH tunnel to our internal network where the team server is, and then I'm SSH'd into the team server, doing a port forward to the CDI pipeline on port 5000. So that is actually all then getting forwarded over an SSH tunnel. So that's why it takes a couple of minutes, because it's going through Azure CDN to Amazon to over an SSH tunnel into our internal network, and then over another SSH tunnel to my laptop. So you can see it's now run the tool. I'm just going to actually, I'll show you again because I think it runs it again. The first example was just running the exe. The second one is giving it some more complex arguments to do like an S4U attack. So you can see the GET requests basically hit the pipeline tool that's running on my laptop, and it's compiling it up. And I'll scroll upwards on this example again in a second. And as I said, the pipeline will encrypt and obfuscate the tool that's run in memory. And I'm going to scroll up here and show you. And it's encrypted with keys that are derived from the environment. So it can only ever be run, even though it's only run in memory, it brute forces its own decryption key and runs it on the endpoint in memory. So that's the first demo. Where's my mouse? Is it on that screen? Yeah, there we go. So what else does it do? Well, I mentioned that we might want to actually evade analysis. So whenever a tool is built, fundamentally what we're going to do is just obfuscate that tool. The reason for this is it makes it harder for anyone who's doing threat hunting based on memory to actually triage what is going on the endpoint, because it's different every time. So you're not going to have two tools that are running, the same tool running on two different endpoints with the same memory signature, because the tool's obfuscated. So this means if you're doing memory inspection, it's going to be harder to actually find these tools running. So the way I approach this is using a library called ConfuserX. And basically, ConfuserX is an open source protector for .NET. It allows you to do things like control flow obfuscation. It will rename all the resources. It will encrypt strings, all this kind of cool stuff that protectors do. ConfuserX is quite simple to configure. Basically, there's a configuration file that sits within the Red Pipe source code. It looks a little bit something like this, and basically you can just pick the options that you want to apply to the protection. So in this case, I'm just saying, rename all the resources. And then Roslyn will basically compile the tools to the intermediate language. It will then use ConfuserX to obfuscate the intermediate language and create the compiled .NET code. So let's look at an example of what this might look like. So what I'm going to do is now just encrypt an actual artifact that we're going to drop to disk to stage something. So the video, let's pull this one over as well. It's a little bit better. Okay, so this time what we're going to do is, you can see down here, I'm basically just saying upload an artifact that I'm going to drop onto this this host. You can see it's now retrieved the artifact from the pipeline, it's dropped it to disk, and you can see the artifact's actually here. And now I'm just going to run the artifact just to show what it does. It basically just stages a new C2. So you can see we've got a new implant running. Another one's just popped up here. We've got a second one on the desktop, workstation. And that is basically just does shellcode injection into Internet Explorer with PPID spoofing. So you can see the parent process is Explorer. If we take the artifact and we drop it into .peek to have a look what it's doing, take a second, what you'll see is that the actual artifact is completely obfuscated. So if we took a look at the various function names, all the resources, you can see it's not trivial to read out what's actually going on in there. And actually, the shellcode that is contained within the artifact is keyed to the host based on the environmental keys that are derived from the endpoint. So you can't actually decrypt it without the keys, and the keys are brute forced every time it's run. So we've got you can create DLLs and exes with this process in .NET. And because this does injection, you can actually also just remove the exe after you've run it, because it just stages that kind of second stage implant. Okay. So I mentioned that we want to actually protect our tools. The reason for this is because if we're developing new techniques, we're writing code on engagements, we might have our own tooling that we want to protect the IP of. We don't want the blue team to kind of find these artifacts, find these tools, and drop them onto VirusTotal, that kind of thing, because they come into the public domain. They're going to get signatured. So because we're using this approach of compiling and programmatically building our tools every time, we can actually key them. So keying is basically the concept of taking a payload, and then we use either a local or remote resource to basically, in this case, AES encrypts the tool based on whatever decryption key. Now, the decryption key may be known. It could be embedded if you wanted to embed it. In my case, I just brute force it based on environmental factors that I read from the environment. Or you could kind of take this further. You could have it so that the key is read from like an SPF record or a DNS text record. You could have, and then once you've done your stage of kind of running your tool, your artifact, you just remove the key, and then it's never actually been in the environment, and nobody can actually decrypt what's gone on. But that's fundamentally what keying does. So what happens is when the loader runs on the endpoint, it does extract some. Extracts multiple environmental keys. If we're using Cobalt Strike, it then the loader gets run with execute assembly, and then the keys are submitted to the RedPipe API. I've also kind of modified this in that you can have it such that the keys are read from the Cobalt Strike data model, so they're not actually ingested through the loader as well. So they're never actually in memory either. And then basically the API responds with the encrypted artifact or tool, AES encrypted based on whatever those keys are. And then the loader brute forces them, finds the entry point, and then uses like assembly.load to run it. The kind of benefit of this approach, this kind of offensive development approach, is really that we don't actually have to heavily interact with the operating system at all. We can do everything that we want to do in code. So if we look at an example, let's say we're on an endpoint, we're wanting to do some discovery. Traditionally, maybe you use something like Findstra or PowerShell to search for files that might be on that endpoint. Now that wouldn't look very pretty in the kind of telemetry within EDR. So how do we kind of solve that? Well, as I mentioned, like offensive development can actually solve that for us, because you can do a whole red team engagement almost just by sitting in your IDE, writing things as you go along. So if we look at an example here, what I'll show you is just one more quick demo. I'll show you how kind of powerful this is. So I've got VS Code open. And I've basically got some C# code that just searches in a user's folder for text files. So I'm just going to tell the loader to run that code now with the offensive development project, and it will, you'll see, it'll just give you a list of text files that exist in the IT admins folder. It takes a minute or so. Okay, so it's brute force the decryption key, comes back, and we've got a list of text files. So what we can do now is, just on the fly, we can just say, okay, search these text files and look for the string password, and let's just add, an extra line saying, we'll just add something, a print statement saying, hello BSides. And all we need to do is just save this and then run the same command again on the endpoint, and we'll arbitrarily run this because it's being retrieved from our laptop every time. So we can actually do everything that we want to do from the IDE. We don't actually have to run any commands on the operating system anymore. So again, you can see here, and it should hopefully, well, it's a video, so it does, give you a different result this time. Yeah, so you come back and you can see now the code's done something different. So we searched through the file, we found the passwords, and we've got our print statement. So what's next? Well, this is still something that I'm working on. It hasn't been widely tested outside proof of concept. I am looking at how we can avoid injection. So my kind of idea at the moment, I've been playing around with a tool called Donut, which will convert .NET exes into position-independent shellcode. So my kind of idea is we don't actually have to inject into a new process and inject a CLR. Why can't we just run shellcode in our own process, and it avoids process creation completely? So that's something I'm working on at the moment. Then I also just need to add more tools, more configs, get it working properly in Docker, and then just release it with some blog posts and things. That's stuff that's on the horizon. Prior work, I think it's only fair to mention Adam, who's sitting up at the back, who did some work on creating DevOps toolchains for red teaming using Azure DevOps. And then also Dave, I don't know if he's here, I saw him this morning, but Dave did a really good project called Shark Compile, which is kind of similar in that it allows you to run arbitrary C# on the command line through Strike. And then finally, we are hiring, so if anybody is interested, get in touch with us. Well, that would play. It's supposed to be a GIF. Oh yeah, it does. Awesome. Great film as well, by the way. And if anyone's got any questions, I've got literally 2 minutes left at the most. Go ahead.
Is it possible to have the team server talk to the web pipe server directly?
Yeah, it does. So that's how it retrieves the loader. So the aggressor script basically retrieves the loader locally, so to your Cobalt Strike client, and then that's how it, because execute assembly works. The file needs to be on your machine, so that's how the execute assembly runs the loader.
Is it not possible to have it so that
you can? So what another idea that I was working on was. Basically, we can create the loader with the tool embedded inside and the arguments embedded inside, and then you run it through execute assembly and you don't need the reverse port forward. That's another option I was looking at. But in that scenario, you can't get the only keys that you'll ever be able to have are from the Cobalt Strike data model. You're not going to be able to get additional keys outside of the environment unless you extract them in another way. So you would have to have like an initial process, like a C# process that runs first, gathers lots of different keys from the environment, feeds them back to the server so it's got known keys, and then you could do it that way. The reason I did it this way of the reverse port forward was just give more flexibility for getting different keys. Any other questions? Come.
So you're basically going away from the living of the lab, I think?
Basically, yeah, because it's noisy as hell. Threat hunters know about all the different commands that people run. It's very easy to build a storyline in EDR based on telemetry of people running commands on operating systems. So
almost referring to all the because you essentially have to re-implement all the commands.
Yeah, so I mean, like I've got my so say I wanted to run ipconfig, I've just got a version of ipconfig that I've run in .NET. If I wanted to run search on the file system, you can just build .NET code up for common things that you might want to do, and then you've got all the existing tooling, things like the GhostPack tools that you can run, and the PowerShell scripts that you can run and bootstrap them through this technique. Is there any more what, sorry?
Is there any more data volumes that are going to see?
I mean, you are going to deliver a .NET exe to the endpoint every time, but they're pretty small, to be honest. So. To see, how do you mean? Sorry, you mean in terms of spikes of traffic?
Detection.
The detection, it's all happening over your normal C2 framework, so it's all encrypted anyhow and wrapped through SSL. So it's still going to be. It's just like running execute assembly on a box anyway. Yeah. Yeah. I think we've got to wrap up. Thank you very much.